Welcome back to the fifth video in this series that's now looking at step 3 of doing the course assignment for networking with client and server for the video series on YouTube. So if we go and look at our assignment where it says step 3, this is where we're up to now. So it says create a basic client called Connect based on the sample client we made earlier in step 1, and then we can test this with our server. So if we go back to Visual Studio, we see here what we had from step 1 from the first video. So we can copy that and we can create a new project, which is a new console application called Connect. And we can paste that in there. So we can save all that, and we can also add the solution to Subversion now straight away into the repository that we're using here, which is visual svn.net.dcs.hal.ac.uk svn and the username. So we've successfully added it to Subversion, and we can commit it to Subversion. Now we can proceed. Right, so before we go to edits, we're just going to say we're now going to update this to make a new revision number. We want to call it Connect. We should start to professionalize it by putting in the comments like we did in the other one. I'm not adding much commentary here, we're just adding the same comments that we've already learned how to do. and we can say what arguments it takes. It takes a /e for echo and /n for no. So instead of networksolutions.com, we need to connect to localhost for our client, and then we can just look. So if the argument's length is exactly 1, and then we want to check that that argument is equal to /n. If it is, we will want to write out so if it's /n, we want to write out the word no-op flash, and we won't be getting anything back, but we might have to check what we get back, so we have to look at the specification. Else, if its arg's length is equal to 2, so probably what we can do here is put a switch to allow for the different number of arg's length, but we'll put an if in for the moment. So if arg's length is equal to a 2, and then if it's not either of those, we could say console write line wrong number of arguments provided. So if it's 2, it's got to be /e. So if args 0 is equal to /e, and then we want to put an else here, and we want to put an else there. Unrecognized command. This one will also be unrecognized command. Right, I'm just going to finish implementing something for the echo, and we need to write line. Whatever the command is, it will be echo. And then we need to add whatever was in the second argument. We just concatenate the strings. So we'll write line that. We can do an SW flash of that, which is very similar to what we sent here before. So that's in there, and we'll probably want to write something out to the console. So we just need to quickly check with our specification what we're supposed to do when we send a no-op and when we send an echo. So here's the specification. So it says the basic command is -n, which is the no-op command, -e followed by a string for the echo command. Here's the examples that our Connect program is going to implement. So it says we have to print out the words echo response and what we got back, or the word no response, and here we have to print no-op response. So if we got a response, we're supposed to say what it is. So it's the command followed by the response. Okay, so we can read that response, so we need to print out the name of the command, and we actually need to print the same for either one, so that could probably be done down the bottom here. Well, so we can do the reading here, and actually we can do the flash here as well. Which means this piece here can just be deleted, and this piece here can be deleted. What we've got to make sure is, once we've had the error message or any of these error messages, we return from the program. Otherwise they go down to here where it does a flash, and we do a read to an end. So we probably want to save our response that we get back here in a string variable, and then we need to write out the name of the command, which would be args zero So it looks like the name of the command, a space, the word response, and then whatever this response was. Let's go back to the thing. The name of the command, the word response, and then whatever the response was. But if there's nothing, we will say no response. So we need to check if there's nothing. And again, we probably need to trim the end of the response here, so then we can say if response is equal to the null string, we would want to put a console write line of the words no response. response there. So we can just check that we've got the text correct again. It's capital N, capital R, so we need capital N, capital R. So it looks like we've got the format of response. We've checked the various arguments. Oh, there's a little dot there that shouldn't be there. Finish filling in the student number. So we can save that, and we can actually commit those changes again to SVN. So we've got the program, got the changes. We haven't got some comments. We need to put some comments in here. So just put a few comments in. So open a connection to the server on localhost at port 43 and set up some readers and writers. If we have one argument, it must be /n. Or no, or comment otherwise it must be 2 arguments and for echo and a string. Flush the server commands and read the reply. Put a suitably formatted reply on the console. So there we are. So the last thing we can do now is build this solution, and we can get ready to test it against the server that we've implemented. Well, that's just about got the comments finished. Just before we wrap up and test it, we need to check that everything is okay. So a quick visual check that everything looks okay, and we haven't missed anything. Remember when we tested the last stage in step 2, we forgot to do the timeouts. So perhaps we should put something in the timeouts here. Before we did client, and then we managed to set a receive timeout. We can set that to 1000 milliseconds, and we can do a send timeout and set that to 1000 milliseconds, and then if we get an error, we've got a try catch, and that will jump and deliver the error message. We might want to check on the format of the error messages that they're okay, and if we go to the specification, there's a brief paragraph talking about the format of the error messages. If a client needs to output an error message, the message must start with the text error. So that looks like something we've forgotten. So that should say error. And we can paste that in the various places where we have an error message. Right, I think we've got that right. So we've got the timeout, we've got the error messages. All looks okay, so we can save that now. We can again commit that. Back up to SVN. Now we made a major change. We can build the solution, and now we can test that against our server. So here we've got the prompt where we had the server, so we could start the server, and here is where we've got a command prompt running the binary of the client, so we could do connect /n, and you can see it connects to the server, and the server's performed it, and we've got the word no response. That actually appears correct. So we could try connect /p hello. We get response hello, and we could try hello there. We get hello there, and we can try it with no arguments, and we get error, wrong number of arguments are provided. This /e response hello doesn't look correct. Let's go back to the specification again. No, it should say connect. It should say echo response. So we need to fix that. So instead of args here, it needs the name of the command that we used, echo or no op. So we probably need to store that in a string somewhere. So we could add string command, and when we're going to send a no op command, we could set command equals no op, and then we could do something similar here. Command equals echo, and then instead of arg0 here, we could just output the command. So we could save that. Let's build that solution. Quickly go back to the testing. Echo response hello there. Echo response hello. That's beginning to look a bit better. So we should run that with the test script like we did before, and now we know how to do all of the professional approaches. So we can run the setup, map the T drive, and then we want to run step 3 test in the command prompt. We want to stop running the server because the script does that. So now we can run the test script, which involves us just running under the T drive this thing called T step 3 test. On the second argument, we do need to give it the name of the location of the server, which is G08241 respond bin debug respond.exe, and we can start running the tests, and it goes through the tests one by one, and it just gives us some quick information about whether our software component works with the other software components satisfactorily. So it does the no op satisfactory, does the echo okay, does the timeout correctly, giving a valid error message. You can see it's launched the server, it's tested the no op and the echo against it, and then it says, do I want some more detailed debugging tests? So yes, it has a disclaimer saying that we're responsible for debugging our own program, but you can see it's sending invalid commands to the server, but then we get OK in all the tests and we passed all the tests. So that's very good. So it looks like the code is satisfactory, so we just have to make sure we save the code and then we've committed any changes that we've made now back to SVN. And our commit program does seem to test it work properly and is committed to SVN, ready for making other alterations. So that's step 3 finished, and then we can go on and look at step 4, which is adding more functionality to the server. So I hope you found that next step